we'll see what will happen for the integral of sec x in the region from 0 to pi by 2. Now to determine the vertical asymptotes, one way is to draw the diagram or the graph of sec x, or in other words what you can do is we know sec x is equal to 1 over cos x, right? And at x equals 0, cos x will be equal to 1, right? So 1 over cos x will not make any problem, right? But at x equals pi by 2, cos x will be equal to 0, right? Then when you consider 1 over cos x, it will have a vertical asymptote. Okay, so in other words, the secant function will have a vertical asymptote at pi by 2. Therefore, since this is the right endpoint, we have this sort of a situation: an open interval at the right endpoint and the closed interval in the left endpoint. So what we should do is we should approach pi by 2 from the left hand side. In other words, we should consider the left limit of our integral, right? And the integral of sec is ln sec plus tan x, that is a standard result. And then when you substitute the upper and lower limits, you will obtain this one. Now this is because you have substituted 0 for sec x and tan x, right? That means you have sec 0 plus tan 0, and tan 0 is equal to 0, and sec 0 is equal to 1 over cos 0, and that is equal to 1. Hence the result of sec x plus tan x will be equal to 1, and don't forget you have a ln in front, right? So and altogether ln1 is also equal to 0. Okay, right? And how about this term? Now we end up with the limit of t goes to pi by 2 from the left hand side in the ln. Now this is limit and this is ln, the natural logarithm of sec t plus tan t. Okay, so what will happen to this one? Now we saw that when t goes to pi by 2 from the left hand side, cos x will go to 0. In other words, 1 over cos x will go to infinity. Now when you say infinity, you should be careful whether it is positive infinity or negative infinity, right? That can be calculated by looking at the values to the left of pi by 2. Now see, if we consider the graph of cos x, right, it has a nature like this, right, where pi by 2 is at here. That means for all the values to the left of pi by 2, for all the values to the left of pi by 2, cos x will be a positive, cos x will have positive value. That means 1 over cos x will also be a positive value. But when approaching pi by 2, cos x will maintain its positivity, but the value will be reduced. In other words, 1 over cos x will be increased positively because the denominator is a positive number. Okay, but say for instance, if we consider the right hand limit, if we consider, now it is not required for the problem, but just to explain the left limit and the right limit, just see what will happen if we consider the same limit that approaches from the right hand side. Then cos x will be a negative value and it reduces negatively. Okay, so in other words, 1 over cos x, now this value will be approaching 0 negatively. In other words, this whole thing will go to a very large negative number. Okay, now if we just disregard the positive or the negative nature, this whole thing will become a very large number because the denominator is being decreased. But since the denominator is negative, the total result will be negatively a very large number. So altogether, if we consider the right hand point of 1 over cos x, or in other words the right hand point of secant x, it will be negative infinity, okay, not positive infinity. But here in this example we consider the left hand point, that means approaching from the left hand side, so it will be positively large number. And how about tan t? When t approaches, now the graph of tan t will be something like this. Okay, and here you have pi by 2. So here we approach pi by 2 from the left hand side, and hence we can see that the tan t graph will also reach positive infinity. That's the nature of this tan curve. So we have a very large number inside ln x, right? And we know that from the graph of ln curve, now if this is the graph of ln x, right? If this x value or the value inside ln term, if it increases, then the value of the function will also increase. In other words, when this is the value inside is very large, the total result of the function will also be a very large number. Okay, so that means the answer for this integral is equal to infinity. And so what we can say is this integral of type 2 improper integral, this one diverges because the answer is not finite.